Good morning dear cadets. So in the last video I taught you some in-text exercise and told you how to solve such kind of questions, okay, but all those were related with the alcohol, okay. Now still two more things I have to teach in the alcohol related with the exam only, and afterwards I will start the ether, okay. Ether is a small functional group, don't worry. Within 2-3 periods I will complete, means before 31st only I will complete, no need to worry, okay. So there is a such type of questions also, conversion of lower alcohol to higher alcohol, conversion of higher alcohol to lower alcohol, okay. So conversion of lower alcohol to higher alcohol means this is example of ascent of series, ascent of series, number of carbon atom you have to increase. So this is methyl alcohol. What is there? Here one carbon atom is there. Okay. So just see, as far as increasing of number of carbon atom is concerned, you have to treat the compound with KCN. KCN. So here what is there? CN is there. One carbon will increase or not. But remember, KCN react only with alkyl halide. So first alcohol should be converted into alkyl halide. How alcohol can be converted into alkyl halide? When it is treated with hydrogen halide, HCl, HBr, HI, okay. So methyl alcohol I treated with HI. So what you will get here? Here minus will be H2O and you will get the methyl iodide. Now you treat with KCN. So here what would be there? Ki and CH3CN. Now number of carbon atom is increased. How many carbon atom is here? CN. And now already I told you cyanide is very important compound. If cyanide is subjected for acidic hydrolysis, so they will be converted into COOH. If they are converted for partial hydrolysis, means if they are treated with basic hydrolysis or partial hydrolysis, then they will be converted into amide. Amide means CONH2, acid means COOH. So if complete hydrolysis is there, CH3C, this group will be converted into COOH. If partial hydrolysis is there, so they will be converted into CONH2. Now if reduction is there, see, this is reducing agent, NaC2H5OH. So they will be converted into NH2, amide group, okay, NH2, amine group, not amide. This is amide group, okay, and this is amine group, okay. We need this one. So just see, subject cyanide for the reduction. So what you have got? You have got the amine. And now in alcohol, I taught you one reaction, treatment or reaction of alcohol with nitrous acid. Nitrous acid can be written HONO. So just see, here give OH, here give N, here give O. This one HONO. You have got ethyl alcohol or not? What is this one? Ethyl alcohol. So you started with the one carbon atom alcohol. This is one carbon atom alcohol. Here what is there? Two carbon atom alcohol is there or not? So that is why this is an example of conversion of lower alcohol to higher alcohol or ascent of series. Another one is conversion of higher alcohol to lower alcohol. This is known as descent of series example. Descent of series. Descent of series. You started with here, what is there? 2 carbon atom alcohol. Means you can say conversion of ethyl alcohol back to methyl alcohol. Okay. So this is ethyl alcohol. See, when alcohol is 1 degree alcohol, if it is subjected for oxidation, product is aldehyde. Here also carbon atom is 2 only. Now if aldehyde is subjected for oxidation, product is carboxylic acid. Here also 2 carbon atom. Now let us come back to the 11th class knowledge. When carboxylic acid is treated with NaOH, then what is the product? Sodium salt of carboxylic acid. This is sodium ethanoic acid or sodium acetic acid, okay. This is, here also carbon atom is 2. But try to understand, when sodium salt of carboxylic acid or sodium ethane OH treated with soda lime. What is soda lime? NaOH and CaO. CaO. This mixture is known as soda lime. Then what would be there? Decarboxylation is there. Decarboxylation means removal of COOH group in the form of CO2. Okay. So decarboxylation would be there. And this COA, calcium oxide, is drying agent. Okay, reaction with NaOH only. So Na2CO3 will come out, minus Na2CO3. Okay, now CH3 and this H, methane you have got. Now here carbon atom is one only. So just see, whenever you want to decrease the number of carbon atom, then you can follow this reaction. Now you will have here one carbon atom only. But whenever you want to increase the number of carbon atom, reaction with KCN, and KCN react with alkyl halide. Okay. So just see here number of carbon atom, descent of series example. Here you have got one carbon atom. Now subject it for the halogenation. Then you will get the methyl chloride halogenation. Now last year also I taught, this year also I taught this reaction. Okay. Now if you treat methyl chloride with aqueous KOH, then what you will get here? You will get here methyl alcohol. So started with ethyl alcohol and getting methyl alcohol. So this is an example of descent of series or conversion of higher alcohol into lower alcohol. Okay. Over this one. Now there are some more questions. Convert the phenol into salicyl aldehyde, benzene, picric acid, benzoic acid, aspirin, salicylic acid. So I hope that you can do this one. How you will get the salicyl aldehyde? Very simple thing is there. This is phenol. This is phenol. Okay. Just a minute. Let me rub this side because place is less. Okay, so just see, convert the phenol into salicyl aldehyde. So I am doing first one now. Okay, this is phenol. What is this one? Phenol. Okay, you know the Reamer-Tiemann reaction. Their treatment with CHCl3 plus NaOH. Okay, just write the main product only. So at ortho position, CHO group will be introduced. Okay, and what you have to for? Salicyl aldehyde. What is that one? Salicyl aldehyde. So you have got this one, salicyl aldehyde. Actually there is one thing, when you treat, yes, here also change is there, Na. Okay, so now at C ortho position this is introduced. Now subject it for acidic hydrolysis. Then what you will get? You will get this one, OHCHO. This is salicyl aldehyde. Okay, this is Reamer-Tiemann reaction. Reamer-Tiemann reaction. Only main product you should write. Okay, so you have got this one. This is only salicyl aldehyde, this compound. Now benzene very easily, just see, this is phenol. When phenol is treated with zinc dust, here what is there? Zinc dust, one step reaction, then you will get the benzene, yes, minus ZNO. When this group will come out, this H will be here, that is why only O is coming out. Okay, this is what to say, benzene. Now what about picric acid? Picric acid can also be converted, just see, this is phenol. Okay, phenol OH. Now treatment with plus HNO3 in presence of conc H2SO4. Here also concentrate HNO3 you should take. Then what is there? At 2,4,6 position, I taught this reaction. This is catalyst H2SO4, NO2, and here also NO2. Okay, 2,4,6 2,4,6 picric acid, 2,4,6 trinitrophenol. Picric acid also you have got. What about benzoic acid? This is a little bit difficult. Aspirin is also easy only, and salicylic acid is also easy. So how you will get the phenol into benzoic acid? Just see this one. Okay, I am writing this side, this one. Just see, this is phenol. Okay, just see, think of this one. Phenol should be converted into benzoic acid. Okay, and what is the formula of benzoic acid? This is the formula of benzoic acid. Okay, so first write down this formula. We can convert this one. Just see, first treat this one with the zinc dust. So here what will be the product? Benzene. Okay, no problem at all. Minus ZNO. Now subject it for benzene can be converted into alkyl benzene. Okay, Friedel-Crafts reaction. Treat this one with the CH3Cl / HNU. This is last year 11th class reaction. So here what you will get? Here you will get methyl benzene. Now this methyl benzene, if it is subjected for, this is rule only, whatever length of carbon chain, carbon means whatever length of side chain is attached with the benzene ring, if it is subjected for oxidation in presence of KMNO4, okay, so this will be converted into COOH group. Even if you will attach here CH2CH3 group, that also will be converted into COOH group. So now this is only benzoic acid. What is this one? Benzoic acid. So you have got benzoic acid. Now conversion into aspirin is very easy, phenol. Okay, so benzoic acid you have got. Now conversion into aspirin, how you will convert? Just see, for the conversion of this one you have to follow the Colway's method. Okay, let me delete this side, then afterwards we'll write. Okay, so just see, conversion of phenol into aspirin. Okay, this is one type of drug. Okay, so this is phenol. First convert this one into sodium phenoxide. So treat with NaOH aqueous here. So this is ONA. Now what should be there? Colway's reaction, CO2. What is the condition for the Colway's reaction? 300 to 400 Kelvin temperature, 3 to 7 atm pressure. Okay, then what would be there? Just see, ultimate product would be CHO here, and here what is there? ONA. Okay, now you can write the final product also, there is no issue. Actually this directly write here COOH. Okay, now subject it for dilute HCl reaction, acidic treatment. So here you will get OH and COOH. Okay, what is this one? This is 2-hydroxybenzoic acid. Now 2-hydroxybenzoic acid should be treated with CH3COO whole twice O acetic anhydride in presence of concentrate H2SO4. I have treated this reaction, means I have taught this reaction. Then this will only react with here phenolic group. COOH will remain unchanged. So here what is there? This, here O, C double bond O, CH3, COOH. Correct? This would be there. But you want to get the salicylic acid. So this is only aspirin. You have got this one. Okay. salicylic acid. This is salicylic acid. This is salicylic acid, and this is aspirin. What is this one? Aspirin. Okay. Yes. Now I taught this reaction. So just see. First you have to convert into Colway's reaction. This is COOH. Let me COOH here. Okay. Yes. Directly. In one step also directly you can write. There is no need of this one, but it is better to write that one. Salicylic acid. This is aspirin. This is one drug. Okay. So over this one, the last one is phenol to salicylic acid. Phenol to salicylic acid. So just see, this is aspirin you have got. Now phenol to, this is phenol. So see, here only up to here you go, you will get the salicylic acid. There is no need to follow very big step. Correct or not? Phenol to salicylic acid. Yes, Colway's reaction only. Colway's reaction. Till here. For getting the aspirin, one more step. Otherwise, up to here only. It is finished. Now, how will you convert? I hope that you got this one. You follow this step till here. Now you have got that one. Salicylic acid from phenol. Same process. Okay. So just see. I will rub this side. Okay. Now this is valid for this one also. Correct or not? There. Now how will you convert propane 2-ol to 2-methyl propane 2-ol? Very simple thing. Just see. First you oxidize propane 2-ol. So you will get the propanaldehyde. Then propanaldehyde should be treated with propane 2-ol. Just see. Convert this one into oxide form. Then treatment with the Grignard reagent. You will get this one. What you will get? You will get this one with the treatment with the Grignard reagent. Aniline to phenol. Many time I taught. Aniline to phenol. This is aniline. Okay. NH2. Now treatment with HONO plus SCl. 0 degree Celsius to 5 degree Celsius. Okay. This is diazotization. So here you will get N2Cl. Then treatment with water H2O. Okay, heat this one. So here you will get the phenol. Simple. Yes, minus HCl. Now ethanol to propane nitrile. Just see, here 2 carbon atom is there, here 3 carbon atom is there. So first of all ethanol. Just a minute. Let me rub this one, will tell you this one. See, ethanol to propane nitrile. This is ethanol. Okay. Treat this one with SOCl2. So you will get here CH3CH2Cl. Now treat this one with KCN. So you will get CH3CH2Cn. This is only propane nitrile. In IUPAC system, cyanide is known as nitrile. What about the first one? First one is, just see. First write propane 2-ol. CH3, COH, CH3. This is propane 2-ol. If you oxidize this one in presence of K2Cr2O7 / concentrate H2SO4. So here what would be there? CH3C double bond O CH3, and here what is there? CH3MgBr, Grignard reagent. Then what you will get? Just see. Already 2 alkyl group is there. 1 alkyl group should be here. So your product will be CH3C. Here also CH3. Here also CH3. And here OH. Okay. You can treat. What is the condition? H positive H2O. Okay. It is very simple. Just see. one alkyl group always furnished by the Grignard reagent. So this will attach here, and from H2O, one H will be attached here. So it is better to write here OH, and this side write CH3. What is the name of this one? 1, 2, 3. 2-methyl propanol. 2-methyl propanol. So you have got all? Yes? Am I correct or not? Just see. In this way, all the conversion is finished. The purpose of teaching this conversion is you should not be afraid when the same question comes in the exam. You should try. Okay? Now I will teach the ether. Okay. So now ether. So what is the functional group of ether? The functional group of ether is this one, divalent oxygen. Okay? This side one bond, this side one bond, divalent oxygen, and 2 lone pair here. Okay? What is the general formula? ROR. This is general formula. Okay? So one is R, other is R dash. Okay? Just for the distinction. Actually they are alkyl group only. Now what is the definition of ether? Alkoxide derivatives of hydrocarbon or dialkyl derivatives of water. Okay, just see. Both I wrote here. What is this one? This is hydrocarbon. This is hydrocarbon. Alkane. Okay. You can write like that also. CnH2n plus 2 minus 1H plus here OR. So here what you will get? CnH2n plus 1, and here what is there? OR. Okay, this is there. Or you can write this way. This is also correct. CnH2n plus 2 minus 1 what? Minus 1 H. Okay. So now CnH2n plus 1 and this plus OR. OR means alkoxy. R means alkyl group. O means oxygen. So if you combine them, so they will become alkoxide. Okay. So just see RH minus H ROR. Okay. Now from the water, what is the structure of water? The structure of water is this one, HOH. Okay. Replace both H by R group. So dialkyl derivatives of water. That can also be told. Generally we are not using water because in organic chemistry water doesn't come. Okay. But hydrocarbon, what is the organic compound? Derivatives of hydrocarbon. That is why this definition is correct. Okay. Now just see types of ether. There are 2 types of ether, aliphatic ether and aromatic ether. So what is the aliphatic ether? When alkyl group is present both side of oxygen functional group. Just see CH3O, CH3, both are alkyl group or not? Another example, C2H5O, C2H5. This is also just see both side what is there? Alkyl group is there. Another one also you can take C3H7O, C3H7. This can be written like that also. CH3, CH2, CH2O, CH2, and here CH3. Similarly, this can also be written CH3, CH2O, CH2, CH3. Now I would like to suggest you, whenever C2H5 is there, you should write CH3, CH2. Okay, then problem won't be there as far as numbering and all these things are there. Always go for the structural formula. Okay, so what are the aliphatic ether? When both side of oxygen group, when both side of oxygen functional group, if alkyl group is bonded, that is aliphatic ether. Okay, what about aromatic ether? When at least one aryl group is present one side of oxygen functional group. Now in standard way, what we can say? Either one or both group are aryl group. Aryl group means C. Aryl means C, just like alkyl group is there. This is C6H5 is aryl group. This is represented by AR. Alkyl group is represented by R. They are represented by AR. So either one or both group are aryl group. Okay, either one means out of two, one. Okay, just see. Actually, you will get the more clarity about the aromatic ether when I will teach you this one. Aromatic ethers are two types. Alkyl aryl ether, or they are known as partially aromatic ether. Okay, partially alkyl aryl ether or partially aromatic ether. They are also known as phenolic ether. Okay, just see. What is the meaning of alkyl aryl ether? When only one group is aryl group and the second one is alkyl group. See the examples of this category. One side CH3O is the CH3 group is there, other side C6H5 is there. You can make like that also, benzene ring, and here what is there, OCH3. Okay, correct or not? So one side alkyl group is there, other side aryl group is there. That is why they are known as alkyl aryl ether. Alkyl aryl ether. Okay. Now we can write like that also. Just see, C2H5O C6H5. So here also just see, one side alkyl group, other side aryl group. So they are partially aromatic. They are not completely aromatic because still one side alkyl group is there. Okay, they are known as phenolic ether also. Another one is when both groups are alkyl group. So they are completely aromatic. Just see, this is oxygen. Just see the example. This is oxygen. Both side what is there? C6H5. C6H5. You can make like that also. This is benzene ring. What is this one? Benzene ring. Here oxygen. Another one. This one, and this one. This and this. Correct or not? So what is this one? C6H5, C6H5. Okay, that is diphenyl ether. Okay, both side what is there? Aryl group is there or not? Benzene ring is there or not? Okay, so they are completely aromatic, and they are also known as diaryl ether or completely aromatic ether. So this is all about the ether. Okay, all about the ether and their classification. There are two more terms which are frequently used in case of ether. What is that one? That is known as symmetrical ether and unsymmetrical ether. Symmetrical ether means when both are similar. Okay, both alkyl groups are similar or both aryl groups are similar. So that is known as symmetrical ether. When both are different, so they are unsymmetrical ether. Unsymmetrical ether. Okay, so just see, there is one more term, symmetrical and unsymmetrical. Okay, as far as the types of ether is concerned. So symmetrical ether is known as simple ether. Unsymmetrical ether is known as mixed ether. Okay, what is the meaning of symmetrical ether? When R and R dash is equal, or AR and AR dash is equal. Just see here, equal means same. Okay, CH3O CH3. Okay, both alkyl group is similar. Okay, another one is C2H5O C2H5. Okay, now C3H7O C3H7. Okay, all are the example of symmetrical ether. C6H5O C6H5. Okay, all are example of symmetrical ether. What about unsymmetrical ether? Just see, in unsymmetrical ether, R and R dash is not equal. Just see, one side CH3O, other side C2H5 is there. So just see, here CH3 is not equal to C2H5. Correct or not? Similarly here what is there? You can write another examples also. Just see, C2H5O C3H7. So here also C2H5 is not equal to C3H7. Okay, now this you can see this one also. C6H5CH2O C6H5. So one aromatic ring is this one C6H5CH2 and another one is C6H5. So they are, I am not talking anything about the nomenclature right now. I am just telling you what is the meaning of symmetrical and unsymmetrical. So I hope that you have got this one. Even this will also come under this category CH3O C6H5. Correct or not? So see, this will here also CH3 is not equal to C6H5. Okay, so these are the examples of symmetrical and unsymmetrical ether. Now nomenclature. So generally what is there? IUPAC nomenclature we are discussing. So in IUPAC system, ethers are known as alkoxyalkane. Just see, ether means what is there? ROR. So one alkyl group should be the part of oxygen, alkoxy, and another R should be the part of parent chain. Correct or not? So just will write, don't worry, just see, will write the name and everything. But remember, all alkoxy group always comes as a prefix in IUPAC system. Just like alkyl group, they are also treated as prefix. Okay. Now there are some rules I wrote here. While naming the mixed ether, bigger alkyl group should be part of parent chain, while smaller or lower alkyl group will be part of alkoxy. Just see here. Now we'll give you some example based on first rule. Just see. See, suppose this is CH3OCH3. So what is the name of this one? This is methoxymethane. No issue. No, why no issue? Because both alkyl group is similar. Similarly here C2H5. What is this one? Ethoxyethane. So one alkyl group is the part of oxygen. Alkoxy means ethoxy. Here what is there? Methoxy. Propoxy also. Just see, C3H7O C3H7. So what is the name of this one? Propoxy propane. Here issue is not there because both alkyl group is similar. Now see the first rule. Now this is also just see C6H5O C6H5. What is the name of this one? One aryl group should be part of oxygen. Phenoxy. What is this one? Phenoxybenzene. Correct? Just see. Now we'll see some more examples based on this one. So I have to rub this side and this side. Okay, then we'll discuss with this one. The most important thing is name IUPAC name of mixed ether and second and third rule. Okay, so whatever example they have given in NCERT book, I will write one side and one by one will explain. Okay, so just see here. These are the examples which are given in the NCERT book. So just see. First two are example of symmetrical ether. Okay, so there is no problem. Anyone can be the part of oxygen, means alkoxy, and anyone alkyl group can be the part of parent chain. And I have already named these two. This is methoxymethane. Okay, methane. This is ethoxyethane. Now just see, this is an example of unsymmetrical ether. So just see, now here 3 carbon atom containing alkyl group, here 1 carbon atom containing alkyl group. So here what is written? While naming the mixed ether, bigger alkyl group should be the part of parent chain, while smaller alkyl group will be the part of alkoxy. So just see, what would be the first you number. numbering of bigger alkyl group always start from that carbon atom which is directly bonded with functional group oxygen. Okay, so the 1, 2, 3, correct? 1, 2, 3 means, remember, numbering should be started from that carbon atom of bigger alkyl group which is directly bonded with oxygen, but it should not violate the longest continuous chain rule also. You should see, like here, just see, actually what should have been, this should have been 1 and 2, correct or not? 1 and 2 or 1 and 2, but this is the violation of octet, means a violation of longest continuous chain. So 1, 2, 3 or 1, 2, 3, correct? Are you getting my point or not? It means numbering should start from that carbon atom of longest alkyl group or larger alkyl group which is bonded with oxygen atom or oxygen functional group of ether, provided it must not violate the longest continuous chain. Okay, so just see here, what would be the name of this one? This is now at one number, which group is there? Methoxy. So 1 methoxy, 1 methoxy propane, 1 methoxy propane, and here what is there? Just see. This is also kind of unsymmetrical ether only. So in such case, what is there? This is methoxybenzene. Methoxy. If you see their structure, it would be like that. This. This is methoxybenzene. Methoxybenzene. Which methoxy? 1 methoxy. Because at one carbon atom methoxy group is there. And what is the next one? Here the next one, just see. This is alkyl group, okay, and it is containing, there is one rule, in case of partially aromatic ether, until alkyl group contain carbon number equal to or less than benzene ring carbon, they will be named as alkoxybenzene. So just see here, in this case alkyl group containing only one carbon atom. In benzene ring, how many carbon atoms? 6 is there. So until alkyl group contain the carbon atom, carbon number less than or equal to benzene ring, they would be named as alkoxybenzene. Alkoxybenzene means alkyl group be the part of oxygen, okay, alkyl group be the part of alkoxy group, and benzene will be benzene only. But just see how the rule is changing. In case of partially aromatic ether, when alkyl group contain carbon more than benzene ring carbon, then they would be named as phenoxyalkane. Just see here, in this case, just see one by one. First you concentrate on second one. So here still alkyl group contain only one carbon atom, so they will be the alkoxybenzene. Here also what would be the name of this one? Ethoxybenzene. But what about this one? Just see here. Here see their structure. This O, and here in the alkyl group how many total number of carbon atom is there? 7 carbon atom is there, and in benzene ring how many carbon atom? 6 carbon atom. So now third rule will be applicable. Now this will be, just see, number it. So 1 phenoxy heptane, okay. You can write this one, just see, CH2 6 are there, na? So you can write like that, CH2, 1, 2, 3, 4, 5, 6 and 7, okay. So at, this is one number, so at one number what is there? Phenoxy group is there. So in the simple language what we can say, if alkyl group contain the lesser number of carbon atom are equal to benzene ring carbon atom, so they will be the part of alkoxy. But the moment they contain, means the moment alkyl group contain more number of carbon atom than that of benzene, so they will be the part of parent chain. Benzene ring will be the part of phenoxy, alkoxy. So here arolxy, isn't it? Phenoxy is the correct word. Phenoxy, just like a alkoxy, phenoxy. So this is 1-phenoxyheptane, 1-phenoxyheptane. And what is the name of this one? 2-methoxypropane. What is this one? 2-methoxypropane. 2-methoxypropane. Okay. What about this one? Just see here. 1, 2, 3, 4. Correct? And now just see. Still this group has got, alkyl group has got the carbon number lesser than benzene ring. So they will be the part of, second rule will be applicable. What would be the name of this one? 3-methyl butoxy, 3-methyl butoxy benzene, 3-methyl butoxy benzene. Okay, butoxy benzene, no problem. Now what about the name of this compound? Just see. Here OCH3, here also OCH3. Okay, so 1, 2. What would be the name of this one? They are 1,2-dimethoxyethane. At 1 number also methoxy group, at 2 number also methoxy group. So 1,2-dimethoxyethane. And what is the name of this compound? Just see. This compound, very important. See, alkoxy group, they are always treated as prefix. Okay, and alkyl group should also be treated as prefix. So if other than alkoxy group, other functional groups are there, then what should have been? Means carbon containing functional groups are there. Then numbering would have started from here. Here what is there? If you start numbering from this one, 1 and 2, then what would be there? Violation of lowest sum rule will be there. Just check here. 1 plus 2 plus 2. Total what is there? 5 is coming or not? 5. But if you are starting numbering from this one, 1 and 2. So 1, 2, 1 plus 1 plus 2. So what is there? 3 is coming. Then what should be there? Numbering should start from here, where two alkyl group is bonded or connected. Okay. And now it is not a violation because they are also coming as a prefix. Okay. So what should be there? You can start numbering from either side, provided they should not violate the lowest sum rule. So what would be the name of this one? Just see. This is 1, 2, 2-ethoxy, 2-dimethyl cyclohexane. What about here? Here just you see. Either you start from here or here. That doesn't make any difference. Because only one substituents are there. But while naming, alphabetical order should be followed. So just see, alphabetically who is coming? Ethoxy, E. This is N. So numbering must be start from here. 1, 2, 3, 4, 5, 6. So 1-ethoxy, 2-nitrocyclohexane. 1-ethoxy. Can I write this side? Just a minute. Here I am writing 1-ethoxy, 2-nitrocyclohexane. Okay. So just you can check. Yes. cyclohexane. Everything is correct. In this way, Iupac nomenclature of ether is also completely completed. Now, structure of functional group is there. Before that one, I would like to teach you the isomerism in ether. Just see the isomerism in ether. So, just see, in ether basically these three kinds of isomerism is found. Chain isomerism, okay, functional isomerism and metamerism, okay. So, as far as functional isomerism is there, already I taught you while teaching the isomerism in alcohol. Ethers are the functional isomers of alcohol, okay. Like this one is there, we can write in two ways. This is C4H9OH, alcohol is formed, and another way, alcohol, and from this one C2H5O, C2H5, okay. Even how to identify that also I taught. If molecular formula belongs to CnH2n plus 2 and number of oxygen is 1, then ether and alcohol will be there. Now C4H9 can be written like that, CH3, CH2, CH2, CH2 and OH, okay. And this can also be written. Not only functional ether and alcohols are the functional isomers in aliphatic hydrocarbon, they are the functional isomers in aromatic conditions also. Just see, this is alcohol, same can be written like that also. Just see, this OCH3, just shift this H here, so you will get this one, or from this one shift one H here, okay. So what would be there? Now just reverse this one, this can be written like that, okay. CH2OH, correct or not? One H here, so this is this one, and CH2OH. In this way, just you can write, both are molecular formula is same only, okay. So this is functional isomerism. Chain isomerism means having same molecular formula but different arrangement of carbon, okay. Just see, this is the compound, this is 1-methoxybutane. We can write this one like that also. Just see, CH3O. Now here CH2, CH3. Now we can write CH3 group here, okay. Just see, the molecular formula is same only. We can write like that also. Just see, CH3O, CH3, CH2, CH3. So having same molecular formula but different arrangement of carbon in the chain. Just check in this compound. Now next one is metamerism. This is a special kind of isomerism which is found in ether and 1 degree, 2 degree, 3 degree amines, having same molecular formula but different arrangement of alkyl group in either side of the ether functional group. Just see the example. Suppose you have written this one, CH3, CH2O, CH2, CH2, CH3, correct. So we can write like that also. Just see, same can be written. Just a minute. CH2, either side, this can be written like that. Just change this one, CH3, CH2, CH2, O, CH2, CH3, okay. Or this can be written, of course they are the same only, they will become same. We can write like that. Just see, CH3, CH2. Now see, CH2, 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 CH3, okay. So just check here, check one side, what is there? Ethyl group is there, other side propyl. Now in this compound what is there? One side butyl, other side methyl. So total number of carbon atom is same only. So the arrangement of alkyl group is different. Now see, this is the compound CH3O, CH2, CH2, CH3. We can write like that also, CH3O CH, CH3 and CH3. Okay, molecular formula is same. Now here in this compound, this is propyl group, this is methyl group. Now this is isopropyl group and methyl group. So arrangement is changed or not? So same thing is here, one side ethyl, other side propyl. Now here one side methyl, other side butyl, but total number of carbon atom and hydrogen atom is same. Like that other example also you can find out and do. Now structure. So the ether structure is bent or angular structure. Okay, water structure you know or not? This is water structure. Oxygen of water is sp3 hybridized, 2 lone pair of electron is there and 2 sigma bond is formed with the hydrogen. Means sp3 hybridization means 4 sp3 hybridized orbital. So out of 4, 2 have bonded with oxygen, 2 are containing lone pair. Same is the case with ether. This is the ether structure. Okay, dimethyl ether, CH3 CH3O. So here also oxygen is sp3 hybridized and carbon is also sp3 hybridized only. Okay, both are sp3 hybridized. Out of 4 sp3 hybridized carbon oxygen, out of 4 sp3 hybridized orbital of oxygen, 2 are containing lone pair. They are containing lone pair. Remaining 2 will make sigma bond with the sp3 hybridized carbon atom of sp3 hybridized orbital of carbon. Okay, here also 4 sp3 hybridized orbitals are there in this carbon. So out of 4, 3 will make bond with the hydrogen and 4th one will make sigma bond with the sp3 hybridized orbital of oxygen. Okay, so this is the structure. Here carbon oxygen bond length is 141 picometer. Okay, and bond angle is 111.7 degree, which is slightly higher than normal tetrahedral bond angle. Normal tetrahedral bond angle is 109 degree 28 minute. Correct? Am I correct or not? So just try to understand here. The bond angle of CH3O CH3 is greater than tetrahedral bond angle 109 degree 28 minute due to repulsion between 2 bulky alkyl group. Just see, this is alkyl group, they are bulky alkyl group, they repel each other. That is why this bond angle is slightly elongated. This is the only reason, that is why this bond angle is, instead of 109 degree 28 minute, this is 111 degree 0.7 degree. Okay, thank you. In this way this is completely completed. Now tomorrow we will start the methods of preparation of ether. Okay, thank you.